Hey guys, I'm back with a new video. In the previous video we had discussed that objects are reference types, but in the end we know that object is made up of primitive types and it represents an entity. Now on the screen you can see a bit complex object which has some properties defined on it, like a name property, age, university, some reference types nested within our object like subjects, the address object, then a isgamer boolean property which is a primitive, and then we have the introduce method that basically helps the student to introduce to us. Okay, so this is all in the student object. On logging to the console you can see we're getting the object getting logged on the console. Okay, so this is our student object. Now let us see more on objects in this video. So even though you can see that student object has multiple nested reference values like the subjects, the address object, you end up with primitive values if you drill into the object. Like address is your reference type. Okay, now when you are drilling into the object you go one level within it, so you are applying nesting. So within the address we have certain properties like this nested within the address object, and these are primitives, and these primitives are helping us to compose a pair reference type which is address. So these primitives are a type of our reference type address, and even these strings are part of our reference type which is subjects, which in this case is an array, as you can see. Okay, so this is what I wanted to tell you about. The primitive values are the core building blocks of an object. Let us see more on objects in this video. Also, I decided to wrap up with objects in this one video because of the reason I have a complete independent playlist on JavaScript objects, where I have literally covered everything you need to know about JavaScript objects. The link for the complete playlist on JavaScript objects can be found down below. Now if you want to access certain properties sitting on the object, we can do so using the dot notation. So what I will do is I will leave a comment here, accessing, and I want to access the name property that is sitting on the student object. So let us check the output in the browser, and you can see that Alex is getting logged to the console. Now if you want to invoke the method introduce that is sitting on the student object, which is this method, I can again do the same thing using dot notation. I can see student object, and within the object we have an introduce method that is defined within the object, and we can invoke it using parentheses. And if I now go back to my browser, we can see it is logging to the console that I am a student of XYZ Institute of Technology. So it is dynamically resolving the value. So first, here we are using template strings using backticks. Okay, and it finally get resolved to I am a student of, and then it is dynamically resolving this value which we are getting from the student object itself, and which is the university, so XYZ Institute of Technology. So finally this gets logged to the console, which is I am a student of XYZ Institute of Technology. Okay, so now let us see how we can add a property to the object once it is already created, which we have already done, which is student object, how we can delete them, and much more. Though I will again emphasize on this that I have covered each of the things that you can do with objects in that complete playlist on JavaScript objects. Definitely don't forget to have a look at that. So if I want to add a new property to our student object, we can do so with the dot notation and then assigning a value to the property. So I will say adding a new property to the existing object. So I will say student object dot isNode and set that to true. Now if I log the student object to the console and go back to my browser to see the output, you can see the complete object getting logged to the console, and we have one extra property added to our student object that was already existing. So isNode property got added to our student object. So this is how we can add a new property to the existing object. Now moving further, let us see how we can basically add more properties to it. So if I want to add a new method on the student object, like get details, and then I say function. So if I say student object dot name is student, I'm using template string, as you can see, student object dot age years old and is a student of student object dot university. And if I now invoke this method student object dot get details, it should definitely get triggered because it is now sitting on the student object. Okay, so now let's see the output of this in the browser. So you can say Alex is 21 years old and is a student of XYZ Institute of Technology. So it did got defined on the student object. So you can basically make use of the dot notation and then the assignment operator and define the values for your properties. The values could be normal strings, booleans, or any type, and even a function as well. Okay, so do keep in mind that if you try to access a property that does not exist on the object, you will not get an error. Instead, you get undefined. If the property that you are trying to set was already present on the object, like isNerd, if I reset that to false, so in that case what will happen is it will get updated with a new value. That is, you can toggle between true and false for the isNerd property or any other property. Okay, so the value will get updated for the property if it was already existing on the object. Otherwise, if you are defining a new property, it will become a part of the object. As simple as that. Now sometimes there might be use case wherein you want to get rid of a certain property defined on the object. So the property is sitting on the object and we want to get rid of it. For that case, you can make use of the delete keyword. Let us see that in action. So if I want to delete the age property of the student object, I can say so deletion of a property from the object. I can say delete keyword and then student object dot age, and if I now log the student object to the console and let us see the output in the browser. So this is our object that we are getting back, and you can see the age property is no longer defined on the object. It is gone. Okay, so on logging the student object to the console, you can see that. So age property is no longer there. We just deleted it. And if I now try to access the age property on the student object, we will get undefined instead of an error. Okay, so let us try that also. Student object dot age, go back in the browser. You can see we are getting undefined and not an error because the age property is no longer present on our object, but you can still access it, and even if you access it, you will get an undefined and not an error. Means the value that you are trying to get for a certain property is no longer there and is set to undefined by JavaScript. Okay, so I hope I made this clear. Now moving further, this means that deleting the property is just like explicitly setting the same property to undefined. So we deleted the age property, but that doesn't mean that it's gone. It is still there, but it was just like explicitly we are setting that to undefined. But again, that is not the recommended way to delete a property, by setting that to undefined. So instead of explicitly setting it to undefined, you should use the delete keyword for removing a certain property that is sitting on the object. So now let us see how we can make use of the square brace notation to access a property that is sitting on the object. In the above object, let me show you one property that we defined that we can access using the square brace notation. Now we have a isGamer property with a white space between words is and gamer. So to access such a property, we can make use of the square brace notation, because dot notation will not work in this case because the property name here is composed of two words separated by a space. So what I will do is I'll go down and I will log student object, and I will use the square brace notation, and I will define the property name, which is schema. Had I accessed that using dot notation, it would not have worked. Okay, so go back to my browser to see the output, and we are getting false because the student Alex is not a gamer. So this is how we can access a property that is defined on the object using dot notation. The square brace notation is an alternative way of accessing properties sitting on the object, and it will work in every case. Now, besides the string property names, there are two other kind of types that you can make use for your property names, and that would be numbers and also symbols. So we can define a number also as a property name, and symbol also, which we will see later. So let us see that in action. What I will do is, if I say student object and I say dot 23 and set that to 23, you can see we are getting error. So this 23, which we are defining as a property, is getting highlighted with a red shade. So what is the problem here? This assignment using the dot notation will fail even though the key that you are setting does get converted to a string, but this is not the syntax that JavaScript supports. You can again achieve this using the square brace notation. So I will just comment this out because this will not work. Okay, and I will say student object, I will use the square brace notation, set a value of 23. Okay, and if I now log the student object to the console and go back to the browser, you can see 23 property is now defined on the object, and it has a value of 23. So on logging to the console, you can see that it does work fine. Okay, so moving further, you can also understand that property names can also be symbols, which of course you will see in a later video. Now let us see how we can iterate over the properties of an object. So I'll make use of the for in loop here to log the values pertaining to the keys sitting on the object student object. Okay, so go back to my Visual Studio Code and let us discuss about iteration in case of objects. So we'll use for in loop. So this is the structure for in loop. I'm using my snippets for this. Let us remove this, and I can say for const key in student object, and I will log the student object key to the console. If you want to learn all about the iteration methods that we can apply on objects, I have a complete video on that. Again, that video can be found in the playlist that I told you in the start of the video. Okay, so this is how you can access the properties and the values pertaining to them using the for in loop. Let us see the output for this. Okay, all the properties are now getting logged to the console. Okay, so starting from 23, and you can see line number 56, which is this. Okay, all properties are getting logged to the console with their values. So on checking the browser console, you can see all the key value pairs pertaining to the object were logged to the console. This is how we can make use of the for in loop to iterate over the object, though I have covered various other ways to iterate over the object, like object.keys, object.entries, .values in a separate video, which is part of the playlist on JavaScript objects. For keeping the video short, I will not be discussing these methods because I do have a complete video on this. So go and check out that video. The link for that is of course down below. Now let us understand the spread operator in context of objects. Though we did cover the spread operator in case of arrays in a separate video, let us see how we can leverage the power of spread operator in case of objects. What I now want to do is I want to clone the student object. For that we can make use of the spread operator. If you want to understand more about cloning and its types, I do have a separate video on that also. The link is down below. So let us see spread operator in action. Spread operator in case of objects. Const student clone object, and use the spread operator again, the 3 dot syntax and the student object. And if I now log the student clone object to the console, so what the spread operator does here is that it takes all the key value pairs that are sitting on the student object. It will merge those key value pairs into the student clone object that we have defined on the left hand side. So it will give you a new object from the key value pairs of the original object. Now let us see the output in the browser. You can see we are getting a new object getting logged to the console on line number 61. Okay, so this is our clone object. This is not the original object, it's just a copy of the original object, and that's a shallow copy. Okay, so now what if I try to add back the age property in our student object that we had earlier deleted using delete keyword or delete operator? You can see that the age property can be made added on the student object. So I can say student object dot age, set that to 23, and if I now log the student object to the console as well as the student clone object to the console, let us see the output in the browser. So on line number 64 is our original object. So we added successfully a age property that was set to 23, and this is now sitting on the original object. Let us see the cloned object, which is a copied one. Here you can see age property is no longer present, again for the same reason that we are copying the original object, and these two objects are now sitting at different memory locations. So their structure will be entirely different because we have only mutated the copy. We have mutated the original object, which is the student object, and the changes will not be reflected in the copy. Okay, that is created from the source data. So the changes are not reflected in the copy, it's just reflected and is confined within the student object. So this is how you can make use of shallow cloning. So you can see that age of property is now sitting on the student object and not on the cloned object, for the same reason that they are two different objects sitting in entirely different chunks of memory. But one thing you need to understand is that references sitting in the object will not get copied. Okay, like the references are your subjects array, your address object, they will not get copied, and they will still refer to the original memory location even after copying. I have discussed the concept of shallow and deep cloning and comparison in a separate video, and this is one of the most important videos. You should definitely check out that. The link is again down below. So let me show you this, what I mean by the statement. If I say student object dot subjects, and I use the push prop method and add a new subject which is changed. So if I now log the student object dot subjects and student clone object dot subjects to the console, so student object dot subjects and student clone object dot subjects to the console, let us go back to the browser to see the output. You can see that the changes are reflected in both arrays. The changed subject got added in both arrays. Again, the reason for this is that the reference, which is the subject, will not get copied. They will still refer to the very same memory location. I'm again emphasizing that. They still refer to the very same memory location. And if you try to make a mutation on the reference, the changes will be reflected across all the copies of the original object as well. Okay, so you can see both of them will have the same state and the same value will get reflected in the array in both objects, the original as well as the cloned object. So to conclude, the spread operator does not give you a deep cloning where we go to all the levels of nested reference values that we might have in the object or array. Instead, the spread operator will copy the top level key value pairs in a new object, and the nested references are kept with exact same addresses and hence they are not cloned. If you want to copy these things as well, you can do so manually. So you have to copy these references manually. The spread operator is doing shallow cloning, so it is not capable of doing the copying of the nested references. I hope I made it clear. So let me show you how we can achieve deep cloning here. So what I will do is I will define a new constant student deep clone object, and I will again use the spread operator for first copying the top level references, okay, the top level key value pairs that are defined on the object. And for nested references, we will make use of some other way to implement deep cloning, because we want to copy the nested references as well, and just using the spread operator will not do that, okay. So I will say student object first, so I say spread operator and then student object. With this, what we do is we copy the top level key value pairs, but for reference values like objects that we and arrays like subjects array that we have and the address object, we will have to do that manually. For that, I will first overwrite the subjects that we spread here in the object, and again make use of the spread operator. So I can say subjects, and I will say dot 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 student object dot subjects. So we successfully made a copy of the subjects array, and it is not referring to the original memory location at which the subjects is sitting. We copied the exact same subjects array, and it is now also defined on some other memory location. So we have this subjects array that is different from this copy. So we have two subjects arrays. One is defined on the student deep clone object and one is defined on the student object, and they are sitting at different memory locations, okay. So with this, we will get a new array of subjects instead of referring to the old array as in the previous case. Now, if I log student deep clone object to the console, student deep clone object and student clone object, and go back to the browser, you can see the both objects are getting logged to the console. Now, if I want to add a new subject to the student object, so what I will do is case not student clone, just the student object. So if I want to add a new subject to the subjects array that is defined on the student object, now in this case we are not referring to different memory we are not referring to different to the same memory location. We are referring to different memory locations because we just implemented deep cloning on the subjects array. Now one subjects array is defined on the student deep clone object and one is sitting on the student object. So these are exactly different arrays. So if I make a mutation, which is the push method, and add chemistry to it, and if I now log the student object dot subjects as well as the student object, student deep clone object dot subjects to the console, let us see whether this mutation affects both the subjects array or not. So you can see that the chemistry subject got added to the subjects array of the student object and not to the student deep clone object. So what does this mean? This means that the subjects array that is defined on both the objects are different objects, okay, are different arrays. So these two subjects array that are defined on these two objects are different arrays sitting at altogether different memory locations. So if you make change to one of the subjects array, like the student object subjects array, the changes will not get reflected on the student deep clone object. Okay, so I hope I made this clear. This is how we can implement deep cloning. So we copied the nested references, which is the subjects, successfully. So you can see that chemistry got added to the original array and not into the copy that we made using deep cloning. Hence the copy that we created from original array did not got affected at all in this case. So this was all about deep cloning that I wanted to discuss. I do have a separate video on cloning, and the video went a bit longer, but if you want to learn more about cloning, the link for that can be found down below. Now let us go briefly over another method called as object.assign to achieve the same effect. Object.assign. Now this assign method is defined on the global object. Okay, so it takes some arguments like the target object, which is the new object that you want to create, and the object from which you want to copy all the key value pairs as multiple sources. So you specify a target argument and one or more sources from which you want to grab those key values and merge into your target object. So let me define the target object, which is the student assign object, and I will say object.assign. I will define the target object, and I will define a source object, which is the student object. And if I now log the student assign object to the console and let us see the output in the browser, you can see that the student assign object is getting logged to the console, and this is a copy, a shallow copy of your student object, which is the source, and student assign object is your target, to which you are grabbing the key value pairs from the source object and copying that to the student assign object target. Now the target might not be an object always. You can also use an existing object as a target as well, and merge the key value pairs from other source objects into that. Now let us learn another key feature of objects, which is known as object destructuring. So if I now want to pull out certain properties from the student object, I can make use of destructuring concept to bring that into action. So I will say, so what I will do is destructuring. This video is indeed going a bit longer, and I'm really getting tired of making such a long video, but okay, finish it fast. Name, and then we have subjects, and then address, and I will grab those properties from the student object. And if I now log these properties to the console, name, subjects, and address, even if you want to grab more properties from a reference type like address, because this is an object, we can grab the properties that are nested within the address, so like state and country also. So this is one more level of destructuring. If I log the state and country to the console and go back to the browser to see the output, you can see New York getting logged for state, for country USA, and then subjects and name also getting logged for your student object. So this is how we can use destructuring. It does work well here. So let us see how we can check for existence of certain properties on an object. To check whether a certain property is still present on an object or not, you can make use of a special keyword. That keyword is called as the in keyword. I will say console.log existence checking. Console log, I will check whether the name property is sitting on a student object or not. So this should basically spit out true or false, whether the property is sitting on the object or not. So it says true because the name property is actually sitting on the student object, and that is why we got true. So this was all about the video on objects. Don't forget to check the playlist on JavaScript objects. I know that this video went a bit longer, but I absolutely covered everything I wanted to accomplish in this video. But if you want to get a deep dive of objects, you can find the link for the complete playlist in the description section. In the next video, we'll learn about a very important keyword, which is this keyword. I could have incorporated this keyword in this video, but to avoid confusion, I decided to make a separate video on that. So if you liked the video, don't forget to subscribe to the channel, and let's catch up in the next video.